Hi, everyone. Welcome to my talk. If you are not expecting to see me on stage right now, I would suggest probably leaving. But this talk is how to stop the Gradle Snatchers. And yeah, it's a talk about Gradle. It's a talk about security. So if you're interested in either of those, stick around. Hopefully, we'll learn something. I'll quickly introduce you to myself. If you've never met me, my name's Ed. I'm a lead Android developer at ASOS. ASOS are a clothing company. We ship clothes all around the world. Hopefully, you might have heard of us or used us previously. I'm also an Android Google Dev expert, have been since November. And I like to talk about mobile security a lot. So I don't know if you've happened to see my talks previously, but my kind of go-to area of speaking about is mobile security. Although I'm not an expert at mobile security, it's something that I'm quite passionate about, something that I like to take the time and learn about. And hopefully, you can join me on that journey today. Obviously, I've got to shoehorn a picture of my dog in there. And I'm still available on Twitter. If anybody's on there, I've been live tweeting this today. I hope this talk will be useful for you. Really would appreciate the feedback at the end of the talk. So yeah, why don't we crack on and get straight into it? I'm going to talk quickly about supply chain attacks. Now, supply chain attacks, if you are unaware, a supply chain attack is essentially an attack on your tooling. It's an attack on the things that you use to build your app. Obviously, this talk is about Gradle, so we're going to be talking about that shortly. But the whole idea of a supply chain attack is to kind of get in that, an attacker get in your tooling without you noticing and be able to kind of introduce a vulnerability or an exploit in that chain. And of course, we really don't want that to let that happen to you. These attacks are quite rare. They're not something that you would necessarily see every day. But when they do occur, they can be incredibly bad. And we will see a couple of examples in this talk today of instances where they have happened. To kind of go into more detail, we're going to be looking at kind of a few critical areas. Firstly, dependencies. We're going to talk about kind of the vulnerability of introducing dependencies in your app. And how we can kind of verify that the dependencies you're using are secure or expected. And then we'll go into the tooling as well, mainly the helpers and the binaries of your tooling. So without further ado, let's talk about the elephant in the room, Gradle. Hands up, please, if you use Gradle at the moment. Literally everyone. Hands up if you don't use Gradle, you use something else. And hands up if you hate audience participation. Yeah, sorry, got to throw that one in there. So yeah, we've had Gradle for quite a while, but I'm sure there's probably a few of you in the room today that possibly remember the time Android existed pre-Gradle. I call this the Eclipse years, but many of you probably know it as the Dark Ages. We've all been there. Again, audience participation, hands up if you're around during the pre-Gradle era. Yes, yeah, I can tell you've all got the gray hairs like me. So it was a fun time. It was the Android development tools with Ant. And yeah, as you can see on screen, if you weren't around, there were some interesting errors. That top left one in particular was my favorite because that's the one I experienced myself. Once we kind of got out the dark ages, in 2012, AGP first came to the scene, and AGP was kind of the first chance for Android developers to get their hands on using Gradle in their tooling. This was a really wicked time, really great experience. It was still with its bugs, but ultimately was a kind of path and a road forward. It took a little while before we got our kind of first stable release. It took a couple of years. And at this point, I think many people had decided to move themselves away from the old Eclipse way of thinking and to the Android Gradle plugin. And now that kind of takes us to where we are today, which is Android and AGP version 8. We've come a really long way, and I'm sure many of us here will be quite pleased to use Gradle on a day-to-day basis. However, of course, this wouldn't be a talk without kind of some stories involved. And the first story that I'd like to talk about today is a confusing dependency. Now, I don't know if any of you have ever heard of this story before. If you have, keep it to yourself. I'm going to tell it again, albeit probably slightly worse. But it is a really interesting insight into an attack that occurred and kind of what we can do in our own apps to kind of prevent that going forwards. So without further ado, let's talk about a confusing dependency. So this story involves Martin. I don't know if any of you know Martin. Martin, I don't know if he's in the room, but he is at the conference. He, back in 2018, in his own words, was quite an inexperienced developer at a company. He's now a Google employee and a DevRel member, so hopefully he's a familiar face. But he was creating a sample app. And in the sample app, he was introducing the very first sort of start of his code base. He decided to import a library. The library itself doesn't really matter for this story. I'm not going to sort of name and shame the library. But all you need to really know is two things. The first thing is that the library didn't have any permissions that it shouldn't have had, or was expecting to not have any kind of significant permissions. And it was also coming ideally from Jetpack.io. I'm sure some of us use Jetpack.io as a Maven repository nowadays. However, when he ran the app, something quite strange happened. He'd only introduced one dependency, but he saw the dreaded missing internet permission error, which puzzled him, because obviously this dependency shouldn't have had the internet permission. So he rightfully took a look at his Gradle dependencies, and as I'm sure this will look very familiar to you all, there was nothing really untoward there. However, what he had failed to realize was that when we use a Gradle file and we use the repositories, it's actually executed line by line. So we will look for the particular dependencies starting at the most prominent repository and going down. So in this example, we would start at Google and check for the dependency. As we were expecting this dependency to be hosted by Jetpack, you can imagine Google didn't host it, and it wasn't there. Then we moved to JCenter. Who remembers JCenter? JCenter was no more. It was a Maven repository offered by, I think, Bintray. And in this instance, for some reason, an artifact did exist. So this is where we introduce the malicious actor here, Fake Wharton. This is actually relevant. Thank you for my very good Photoshop skills as well. So Fake Wharton was a user, and this is legitimately what happened, was a user, as you can see, slight variation on the name Jake Wharton with an extra A, who introduced a repository where he was hosting essentially fake and cracked versions of popular dependencies. So in this case, when it went to JCenter, JCenter had a vulnerability essentially allowing anybody to upload any artifact, and the artifact in this case was resolved. And what that meant is that instead of getting the library that Martin expected, he ended up getting the library from JCenter, and ultimately all of the bad stuff that came with it. In this case, I think what it was doing was sending the user's data, i.e. I think it was the device name and configuration, to a remote server, which, yeah, could be used for nefarious purposes for sure. So essentially, the long story short of this is, obviously, we're really glad JCenter's gone, and also we should trust no one. When I say that, obviously, when it comes to dependencies, we are putting a lot of trust on other developers. We're putting a lot of trust on, on kind of, I think Martin just walked in as well. Hello, Martin. You've just missed it. So yeah, I would say also Martin has done a wonderful write-up of this that you should definitely check out. But yeah, you want to make sure that there is trust when it comes to dependencies. So how do we do that, especially in Gradle? So let's look at dependency verification and the kind of questions we need to be asking. The first question is, are my app's dependencies legitimate? And we can kind of figure that out in two ways. The first way is checking whether the integrity is compromised. So what I mean by that is making sure that the code you're expecting is the code that essentially is returned to you. And then also that the origin is not compromised. So the origin or provenance is making sure that the person who is giving you the dependency is who they say they are as well. And this also kind of applies to transitive dependencies as well, so the libraries that your libraries are using. Gradle offers a great solution for this. It's checksum verification and signature verification, and we'll go through these both now. So we'll start with checksum verification. So checksums, if you don't know, checksums are something that you can do on any file. It's basically a hash of the file, and there's different algorithms that you can use for this, the most common ones being MD5, SHA-1, and SHA-256. However, MD5 was proven to be broken very, very early on. In fact, I think if you have an Android device, you can probably crack an MD5 or cause a collision in probably about 30 seconds. So MD5 is a big no-no. And SHA-1, while requires a lot more computing power, has also been proven by Google in 2017 to also be fairly insecure and not necessarily the best algorithm. So we move on to SHA-256. SHA-256 and upwards is a good algorithm to be using for this. And a hash is very straightforward to compute. You can do this on the command line. It takes literally 10 seconds. I've got two examples there, one with SHA-1 and one with SHA-256. I'm pretty sure that SHA-SUM is something that comes on most Mac or Linux distributions. I'm not sure how you do it on Windows, so apologies, Windows users, but I'm sure you can figure that out. And yeah, this is an example of just a very basic hash of a text file. So let's actually look at some Gradle stuff now. So if we want to be able to get our SHA-256 of the dependencies and our artifacts, we need to run this Gradle task. The task at the end in the brackets is actually optional, and the purpose of this task is to allow for discovery of different dependencies. So depending on your application's configuration, you might have dependencies which are exposed and aren't exposed depending on the particular configuration you're using. So task is optional here. If you don't use it, it will use Gradle's default task. If you specify a task, it will then find the dependencies for that particular task and also write the hash. So once we run this, you'll find a brand new file in your folder, in your Gradle folder, and that's called verification metadata. And in this folder, you'll unfortunately get some XML. XML, I know, isn't our most favorite sort of construct, but it is something that is used here. And at the start, you will see at the top, we kind of have the configuration. So the configuration in this case is that we're going to be verifying the metadata. We'll talk about verifying signatures shortly, but essentially, when you create this file with the kind of above command, you will get this configuration. And also within this configuration, you'll get the components. So let's actually look at a legitimate Jake Wharton library, Timber. I don't know if anyone uses Timber. Timber's great. I like Timber. If I wanted to verify that I have got the right version of Timber, what I'd need to do is obviously add Timber to my dependencies list, run this, and I would get this auto-generated artifact. And what this does is it creates, obviously, an artifact for each kind of bit of metadata that is imported into your application. So in this case, Timber uses an Android AAR file. And this is the SHA-256 and SHA-512 value that would come with that. So how it works behind the scenes is obviously it fetches the particular file from the Maven repo. In this case, it would be the .SHA-256 and .SHA-512, and adds the value from those files to your configuration file. But what happens if there's a mismatch? What happens if you download something and it's the wrong version and it doesn't match? So there could be an issue where, for example, you manually enter a SHA-256 or manually enter a SHA-512, and that's perfectly acceptable. This is also, whilst there is this automated process, this is something that you should actively also be doing manually. If there is a mismatch, there's some things that will happen. The first thing that will happen, hopefully, is that you will get a failed build. Nobody wants to be building anything when you are building with a dependency that you don't trust. However, to get this output, you will need to add a flag to your Gradle properties file. The flag itself, I think, just adds extra information. But if this wasn't enough, if it's just not enough to fail on the console, you can also get an HTML readout. So this is something that you could obviously put within your CI pipeline. It's something that you could publish and make sure that all of your developers within your team are aware of when these issues occur. So that was dependency. So that was the metadata verification. Let's move on to signature verification. So signature verification being the provenance, the origin, and making sure that the person that is distributing the library is the one you expect. By default, many public Maven repos often require signed artifacts. So if you've ever published to Maven Central, for example, you will need a PGP key and for your artifacts to be signed with your particular key. Confusingly, the PGP open standard is usually using a tool called GPG. So if I get those intermixed, it's because, yeah, it's a bit confusing. But essentially, you would use GPG to create a key pair and then upload your public key to a key server. I believe Maven Central requires one of 3 key servers, one of them being the MIT key server, which we'll see shortly. And then once you've kind of signed your artifacts, so that's your AAR, your POM file, everything, you will be able to upload that to the Maven repo. So the setup for this is pretty much exactly the same. You can see that there is a very short difference. In this case, we've got comma PGP at the end. Again, there is an optional task here. I've omitted it here, but you can add a task if you need to get other dependencies from different configurations. And what this does is exactly what we'd expect. It also turns on the verify signature bit in your configuration and then begins to add trusted keys. Now, these trusted keys, these IDs, these aren't actually, I believe, the keys themselves. The keys are fetched from your Maven repo and then downloaded. So for each file, you will get an associated ASC file, and that ASC file, I think, is a public digest of your the file and after it's been consumed by the key. And here's kind of a live example of how this would work. So in this case, we're fetching, we're trying to verify the Timber AAR file. In this case, I don't have the key, the public key for Jake Wharton installed, but this can be fetched, as I said, from the MIT key server. And once that's fetched, we're then able to verify against the ASC file with Jake's public key. So in this case, something to note is that the key has expired. And that doesn't necessarily mean that this isn't a valid file. It just means we'd only really care about this if the key wasn't valid when it was signed. The key was valid when it was signed, so this isn't a problem. So you can have expired keys signing artifacts and still be OK. So hopefully that makes sense. Whizzed through that, so hopefully that's all good. Not sure what that was. So yeah, there are kind of pros and cons to this process. The first thing is that you gain trust in your app's dependencies. I think it's really important to know what you're putting into your app, and I think we are quite often blindly putting stuff into our apps, and that's kind of by design. I guess Gradle makes it super easy to add stuff, but we should always be trying to think about that kind of, different kind of threats to our applications, and certainly dependencies is certainly a valid one. There is flexibility in the type of verification that you can use, as we've kind of seen. We can kind of go hardcore with the checking the provenance of dependencies, or we can kind of just ensure that we are doing the right metadata and everything is kind of checks out there. This is a supply chain attack that has occurred. This is something that if Martin hadn't found, would have probably have gone unnoticed for quite a while. So this is something that should be taken seriously. Definitely going forwards, I think, this should be something that you should consider. And of course, you will sleep a lot better at night knowing that you are kind of protecting against this, and so will I, because I will feel good that knowing that you've done it as well. The cons of this process, this isn't frictionless. Of course, when it comes to security, it's not straightforward. it is going to require quite a lot of manual effort to make sure that your files are maintained and up to date, and you will get a lot of builds and processes failing kind of in the interim whilst you're working on it. And the other thing that I must highlight is that you must start with 100% trust in your dependencies. So you can't just run that Gradle script tonight and think, oh, I've done it, it's done. No, you need to make sure that every dependency is already secure, it's already what you want before running this process. Otherwise, you may be just verifying that you're introducing a bad dependency. So this is a really important note, is that if you are going to pick up this process, is to definitely make sure that you start off with that level of trust. The other bad thing, I guess, is that this is currently all XML, and we don't overly like XML. I think as developers, Android developers, we've all moved away from XML. We've all been trying to move away. It's still there. Unfortunately, this is all still XML. I have been told that Gradle are potentially working on a new solution, but they won't tell me quite what. So fingers crossed we get something good there. And actually, the simplest solution, which is a bit of a weird recommendation, is to ship with no dependencies, which sounds quite mad when you say it out loud. But in truth be told, a lot of fintech apps, a lot of banking apps, a lot of apps where security is paramount, ship with as minimal dependencies as possible for this precise reason. If you have all your code in-house and everything is kind of verifiable from where it comes from, you haven't got a problem. So we should certainly not, I'm not saying don't use dependencies, that's certainly not the takeaway I'd want you to get from my talk, but certainly consider verifying them, consider, if you are working in a secure setting, maybe trying to do as few as possible. There is another sort of side to what we can do to kind of fix this confusing dependency problem. It's slightly less secure, but it is repository filtering. And this is essentially a filter on where dependencies can come from. So you can put filters on different repositories, as we'll see. And there's rules to kind of include and exclude, for dependencies and plugins. I believe this has got a vulnerability in itself, so you would need to make sure that you're using Gradle 7+. Hopefully, the majority of us here are. But essentially, it would look like this. So for example, here in our Jetpack configuration for Maven, we may want to include dependencies from certain groups or certain modules and exclude groups by particular groups, modules, or regular expressions as well. So in this case, we would have all com.example modules and dependencies come via Jetpack, and we would exclude any that come from me, obviously, because why would you want any of my dependencies? So this is kind of a really good, I guess, thing that can be done quite quickly. Again, not frictionless, but certainly introduces some level of security, but it doesn't verify that the dependencies you're getting are legit. It just makes sure that they're coming from the right place. So yeah, like I say, you can gain the trust from your dependencies that come from the right source. This also eliminates the ordering issue that we discussed. So it didn't matter if Google's the first repository or the last repository. If you have filtering involved, if all of the rules are kind of mutually exclusive, hopefully, fingers crossed, they should all be coming from the right places. You can create really simple or crazy rule sets depending on your kind of needs. And ultimately, this also means that you don't leak dependencies, and by that I mean pinging servers with requests for dependencies that they don't have. So this is also another layer of security there. So that's the first story. Let's move on to winter 2022. This is a really cool story. I like this story a lot. But the story starts with a question: where is a great place to see hacking in the wild? Any guesses? No. Minecraft. I never thought I'd be at DroidCon talking about Minecraft, but here we are. So there is the relevance to this story is Minecraft. I promise that this is all relevant, but I want to talk briefly about Minecraft Online. Minecraft Online is a huge multiplayer server for Minecraft. It has over 290,000 unique players, and is actually the oldest Minecraft server to still be playing on the same same multiplayer map. I believe it launched 1 hour after the functionality in Minecraft was released. So yeah, they've been around a while, and this is all relevant, I promise. And it's relevant because Minecraft servers use plugins. Minecraft servers are essentially JVM language projects, and Gradle is often the build system used. So the exploit I'm going to talk about here in the in this story is still relevant. It still could happen in an Android world. It just happened to happen in a Minecraft server. So what happened? So there was a banned player. Somebody got a bit salty, broke the server's rules. And what they did was essentially, through social engineering, became a totally legitimate player. They managed to socially engineer the team to believe that they were someone else, someone that was quite good, and eventually to the extent where they were promoted to being a dev team member, meaning that they had access to the repository and all of the files associated. So this bad actor had managed to socially engineer themselves into a position where they were able to kind of modify quite a lot of stuff. They were able to commit a malicious version of the Gradle wrapper. On first glance, if you saw that in your pull request, would you bat an eyelid? Probably not, right? It just looks like a standard kind of commit. But what they actually did was take that malicious Gradle wrapper and apply it and have it so it was only applied on a CI pipeline. So when their CI pipeline for this Minecraft server ran, what they inadvertently did was allow an exploit into a particular plugin, which gave them access to the underlying Minecraft server and the Linux hardware underneath. So this user was able to steal user information. They were able to exploit the game. I don't know if that was the biggest of their worries, but they were able to exploit the Minecraft game. And ultimately, a very, very bad time for everyone. This was the first public known supply chain attack on the Gradle wrapper. And Gradle did a really good kind of post-mortem and blog post about this, and I thoroughly recommend you check out their blog for that. But there is kind of some prevention now available for this. We can verify the wrapper's integrity. We can verify that the binary we download from Gradle is legitimate. And also, publicly, Gradle also announced with every major and minor release the wrapper and distribution hashes so they can be checked. If you want to kind of do this yourself, if you want to test the Gradle wrapper itself is a jar file and is something that you will have checked into all of your projects, whether you like it or not. In fact, I think Gradle says there's over 3 million Gradle jars on GitHub alone. I have written a very, very hacky script. I'm not a great script engineer, so please don't code review me too much. But there is a script that you can kind of copy from this address and a QR there that will allow you to kind of verify that your wrapper for your particular version of Gradle is legitimate. But if you also don't trust me, there is a much easier way to do it if you are using GitHub CI. There is a Gradle wrapper verification plugin, or action, I should say, that you can use straight away in your builds. It is as simple as just clicking the button, and you get free wrapper verification. And all of the problems that are kind of discussed would go away. So yeah, highly recommend that you use this. If you can't use that, then obviously, please use my terrible script. But yeah, obviously, the GitHub action is probably your first choice. So there are kind of pros and cons to obviously this as well. The pro of verifying the wrapper is that it's mega straightforward. In fact, you could probably do it before I finish the talk. I would recommend not doing it because that would be quite distracting, but you could. It easily slips into most CI pipelines. So this is something that you're going to be able to do very, very straightforward. And like I say, GitHub users pretty much get it for free. So it seems like a really good, extra security thing to have on your CI. The cons, it's still fairly unlikely to be an attack vector. If you are in a position where you've been socially engineered to the extent where somebody is able to kind of change your Gradle wrapper without you knowing, then you're in for a pretty bad time anyway. But otherwise, I can't really think of that many other cons. I'm sure somebody can come and tell me afterwards. Next up, let's talk about verifying the distribution. So the distribution here is the actual Gradle binary that you will download. So the Gradle wrapper will fetch the Gradle binary. And you may have seen in your Gradle wrapper properties this distribution URL. But what you can actually add is the distribution SHA-256 sum. And what this does is, from the previous link that I shared in the slides, is you're able to get that SHA sum and verify when this binary file is downloaded, whether you have downloaded the correct and expected file. So you can set this up manually straight away. You can set this up just by adding this property in your Gradle wrapper properties. However, what I would say is that for this to actually work effectively, you'll probably need to clear your cache and make sure that the binary file is actually downloaded so that check can occur. However, if you are using CI, it's quite likely that that might work immediately. Alternatively, if you upgrade your version of Gradle at some point using the wrapper, you can also add an extra flag. I've obviously omitted the massive SHA-256 string, but essentially you would put your SHA-256 that you would have got from the Gradle website in here with your Gradle version, and this will automatically verify that the distribution you're using is legitimate. But what does it look like when it fails? It looks something like this. Obviously, it will try and download the particular file, and the verification check will fail. You'll get a build error. You will not pass CI. You will not collect £200. So the pros of this, very straightforward. It guarantees the integrity of your Gradle distribution. It is, again, super simple to set up. This is, I think, the common theme that I'd like for you all to take away is that this kind of setup is not really too difficult. I'd say the dependency stuff is the most difficult, but when it comes to verification of tooling of Gradle, they've made it very, very straightforward. And the verification itself is quite quick. So this fails almost instantaneously. It takes as long as it does to take the download of the Gradle binary, and then the check is almost instantaneous. So this isn't something that's going to be eating up your CI time or money. Sorry, it's very distracting. So yeah, the cons of this, again, is to remember to update via the wrapper. I can't really think of any other cons. It is so straightforward that I feel like this is something you could take away and probably implement quite quickly. So one thing I think, and actually this came off the back of a talk I had last night, was that we don't have currently the ability to verify the Gradle W file. So the Gradle W file is the shell or bash script that's kind of used to run the majority of your Gradle tasks. It's often quite overlooked, and there's no official process for verifying this file. In theory, it's a shell file, so it would be, it could execute some quite nasty commands. It's something that, again, if somebody is socially engineered or got access to, could change and potentially for malicious use. There is no, like I say, no official process for verifying this, but you can roll your own solution here. I know a couple of people that do. I'd say that probably the best protection here is to have a very thorough PR review process. Hopefully, the majority of you do. But if you don't, definitely, this is the type of thing you'd want to catch. There is an open issue for this, and I would really love for people to give this a thumbs up. I think what I would like to see happen is a kind of opt-out functionality for the GitHub action that we've just discussed, where this could be kind of implemented. So please do me a massive favor and give a nice thumbs up to that, because that would be really cool to have. I've flown through this, so we're going to summarize. Again, Gradle supply chain attacks are incredibly rare, but they have occurred, and we've seen a couple of examples here of when they do occur, and they can be incredibly nasty. It is super straightforward to kind of get in a way of avoiding these. So certainly you want to consider dependency verification. We've seen a couple of ideas on how to do that, repository filtering, for example, to ensure the origin. But you can also verify the tooling as well. We've seen how to verify the Gradle wrapper itself, the jar file, and how to verify the distribution. But if this talk hasn't really done it for you, you want to learn some more, you want to possibly get some better information, there is a really great talk that I wish I'd seen a lot earlier by Cedric from Gradle. And he is, I think, the principal software engineer for Gradle. And he did a great talk at Devox 2019, essentially on this subject. I've got the title written down. It is Protecting Your Organization Against Attacks via the Build System. I'd say, as a follow-up from this talk, 100% check that out tonight. Well worth a watch. The Gradle security documentation is also extensive and very, very well written, so certainly give that a check out. And obviously, you can speak to a human at the Gradle booth. They're very, very nice, and they've been very kind. So yeah, I think that is pretty much it from me. Please do check out my website. I do like to talk about mobile security. I go into a lot more detail on a lot of different subjects. So if you found this interesting or you just want to hear me ramble on more, you can check out spaghetti.dev/talks. I would also really appreciate a thumbs up via the talk feedback app. So if you've got the DroidCon app and you want to give some feedback, be honest. You don't have to give a thumbs up, but I would really appreciate it. If you've learned something, great. If you haven't, let me know, and I can do better next time. And that's it. Thank you so much for having me. It's I think my first time at DroidCon Berlin, so it's been really, really great. I've really enjoyed everyone. And yeah, thanks for having me.